This lecture is for MSc second semester, paper 4, compiler design, unit 2. It is on the topic scanning and parsing in compiler design. In this video, I will be teaching you about scanning techniques in compiler. These are the various topics which I am going to cover. Scanning overview, scanning techniques, and scanning translation. The term scanning is also called lexical analysis in compiler design. Scanning is a technique in which when we write a program or codes written in the program are compiled, the scanning or the lexical analysis part first checks each tokens in a program, whether there is any mistake in the written code, and accordingly lexical analysis is done so that we can compile the program and run the program. Lexical analysis is the very first phase in compiler designing. A lexer takes the modified source code which is written in the form of a sentence. In other words, it helps us to convert a sequence of characters into a sequence of tokens. It is the function of a lexical analyzer to break this syntax into a series of tokens. It removes any extra space or comments written in the source code. Programs that form lexical analysis are called lexical analyzer or lexers, or even it is called as a scanner. Some of the basic terminologies we will be using in this study is lexgame. It is a sequence of characters that are included in the source program according to the matching pattern of a token. We know when we write a program, we have many tokens in it. And if the token has any spelling mistake, that will cause an error during compilation. A token is a sequence of characters which represents a unit of information in the source program. Every token, like a programming C, if we have tokens like int, printf, scanf, etc. So this is a pattern which is understood by the compiler. For example, in programming languages, keywords, constants, identifiers, strings, numbers, operators, and punctuation symbols can be considered as tokens. For example, in C language, the variable declaration int value is equal to 100. In this, we can see it contains tokens like int, which is a keyword, value, which is an identifier, and the value 100 is a constant, and a semicolon, that is a symbol. And these are the various tokens which are formed during compilation. Let's look into the various scanning techniques. In this scanning technique picture, we can see that the source program, the code which we write in the program, are provided to the lexical analyzer. This is also known as a scanner, which scans each word from this program and converts it into tokens. This is the second step where the tokens are provided to the parser. And this process continues, giving the tokens to the parser and the parser asking for the next token from the lexical analyzer. And the compiling starts after this. The lexical analyzer and the parser are dependent on a symbol table, which we will learn in the next lecture. On receiving this command, the lexical analyzer scans the input until it finds the next token. It continues for the whole program. When the lexical analyzer reads the source code, it scans the code letter by a letter, and when it encounters a white space, operator symbol or special symbol, it decides that a word is completed. A token is understood by a white space. For example, int value. There is a white space here. So it understood that int is a token and this is another token. What does a lexical analyzer do in a compiler? It helps to identify the token in the symbol table. It identifies each token, removes white space and comments from the source program. Each token is cleaned and the white spaces are removed. Correlates error messages with the source program. It provides error messages for a particular kind of mistakes which we have done in writing the token. It helps you to expand the macros if it is found in the source program. If there is a macro, it expands and runs that macro during the source program. Read input character from the source program. Whatever input we give into the program, that is accepted by the source program, and that is also taken as input characters. Lexical analyzer needs to scan and identify only finite set of valid strings, tokens or legime that belong to language in hand. It searches for patterns defined by the language rules. Let's see this with an example here. This is a code. This is a small program in C having some tokens here, which is a function with 2 parameters and the program with a very small statement. We see that examples of known tokens and examples of tokens created by the lexical analyzer. See the comments, preprocessor directives and macros and the white space. These are separately taken up. And legimes, as we all know, are the things which are taken, tokens which are created for further use. These are all known as legimes. Next, lexical error. Whenever the token which has been accepted by the lexical analyzer is not according to the way it wants, that is known as a lexical error. If a token is having a wrong characters, then a lexical error is thrown. Lexical errors are not very common, but it should be managed by a scanner. Misspelling of identifiers, operators, keywords are considered as lexical errors. Generally, a lexical error is caused by appearance of some illegal characters, mostly at the beginning of a token. So, lexical error can be corrected by the human when the programs are run. Without correcting these lexical errors, you cannot move forward into running the program or converting a program into an executable form. Error recovery in lexical analysis. Whenever there is an error in the program, it can be recovered by using the following techniques. Lexical analyzer removes one character from the remaining input. In the panic mode, successive characters are always ignored until we reach a well-informed token. By inserting missing characters in the remaining input, replace the character with another character, transpose 2 serial characters. These are the various error recovery techniques which a lexer uses during its process of converting a token into token for further use. We can see the difference between lexical analyzer and a parser here. Lexical analyzer scans input programs, but parser performs syntax analysis. Means only input is taken in a proper format by lexical analyzer, but the whole sentence is analyzed by a parser. Identified tokens. Each token is identified by the lexer. Creates an abstract representation of the code. Insert tokens into symbol tables. And also, lexical analyzer inserts tokens into the symbol table such that it can be used further by the parser. Update symbol table entries. It generates lexical errors, as we have learned about lexical errors, and corrects it. It generates a parse tree of the source code. A parse tree is an important aspect of a parser in which a tree form of the whole sentence is created such that the compiler do not make a mistake in accepting the code in a sentence form. We see the various advantages of lexical analysis here. Lexical analyzer method is used by programs like compilers, which can be used to parse data from a programmer's code. After going through lexical analyzer only, it creates a compiled binary executable code. It is used by web browsers to format and display a web page with the help of parsed data. Parsing is also a process of accepting the tokens in a particular format only. A separate lexical analyzer helps you to construct a specialized and potentially more efficient processor of the task. Now let's see the disadvantages of lexical analysis. You need to spend significant time reading the source program and partitioning it in the form of tokens. Every program has to be separated into tokens. So it takes a significant amount of time for reading and partitioning it. Secondly, some regular expressions are quite difficult to understand compared to the PEG and EBNF rules. More efforts is needed to develop and debug the lexer and its token description. To create a lexer, much effort is needed. Additional runtime and overhead is required to generate the lexer tables and construct the tokens. These are some of the advantages of lexical analyzer. This is the summary of our study. We can go through it once again. Lexical analysis is the very first phase in the compiler program. Lexgeme is a sequence of characters that are included in the source program, which is matched as a pattern. Lexical analyzer is implemented to scan the entire source code of the program. Lexical analyzer helps to identify tokens into symbol tables. It removes one character from the remaining input, useful for error recovery method. The scanned input is given to the parser, and unwanted tokens are eliminated. And also the biggest drawback of lexical analyzer is that it needs additional runtime overhead required to generate the lexer table and construct the token. Thank you.